So we have seen graceful termination of a connection. Next, we are going to see how non-graceful termination happens. That's what we are going to see in this video. So we are going to look at non-graceful terminations and how the non-graceful termination looks in different tools we have seen. So one thing I would like to mention before we start is whenever we end this Python program, after this print statement right here in line number 12, when we end the program, it is a clean exit. There is a lot of code Python runtime is executing after this line number 12. There is hundreds of thousands of lines, instructions, which is being executed. We can't see it. Long story short, a Python program doesn't end at line number 12. The Python runtime cleanups all the objects. The garbage collector cleans up all the objects we have created in the program. As part of that, it calls the clauses. For example, we didn't have this clause before. Python was doing it. That's why we were getting that finag. Now, we are not closing this socket. This object we are not cleaning up. This yes, the listening socket. That is also done by Python when we stop the program. Now, how to avoid or how to terminate this program in a non-graceful way by not allowing the Python to do the cleanup. So one way is ending the program in the debugger. For example, I have put a breakpoint at line number 6 and I'm start debugging. I have started debugging. And then if I press this button, the stop button, none of these lines are getting executed, including the cleanup code Python would have executed after line number 12. So this is a very common Python thing, or for any programming language. If you stop the execution in a debugger in the middle of the program, which can be done in almost all the debugger by definition, the program will have a non-graceful termination. Another way to do exactly same thing is going to Task Manager and right-click End Task. If you do this, again, there'll be non-graceful termination. What is the difference between graceful and non-graceful termination? Very simple. In the case of graceful termination, you are doing your cleanup. Whatever resources you have created, whatever ports you have opened, databases, connections, objects, memory, devices, everything you are doing, cleanup, whatever you have done. But when you don't have a graceful termination, when you're dying prematurely, you don't have time to do anything. You don't know that you're going to die. So you don't have time to do the cleanup. So that is what we are trying to emulate here by stopping from the debugger. And we are going to see how that looks inside the trace and different tools. So as usual, I'm going to start the server. So our Wireshark is running right here with the display filter. It's the exact same display filter we are having on port 65432. That's our port. And server is running at the moment. We do have TCP view running in the background. We have seen this tool. And again, in TCP view, I have this filter 65432. This is our server port again. Now I have a procmon as well ready in the background, but I'm not running it right now. So I need to press this button to run it. So first we will look at other tools and come back to procmon later. So our server is running and I'm going to start the client. The client, I have a breakpoint at this particular line after connect. So let's see that. So I'm going to put this here. So there is synac ACK. So we have the TCP handshake, three-way handshake, because the connect is successful. Now, what I'm going to do is instead of executing line number 9, so I have done the connect, server is waiting for further data from the client. I'm going to terminate the client. So I'm going to end the program. I'm not going to execute anything after line number 8, including line number 9. I'm not going to execute. So I'm going to press Shift F5 or stop right here. So as you can see, the server was waiting, and in the server, so this is the server, the screen switched pretty quick automatically. As you can see in the server, I have terminated the client, and the server, we got this particular exception. An existing connection was forcibly closed by the remote host. So all these adverbs, forcibly, actively, all those things are important. We have seen actively rejected by the remote host, forcibly closed by the remote host. So all this means that the remote host is doing something to close the connection. Now, what is it doing? So let's look at our network trace. So as you can see, after the SYN/SYN/ACK, the client is sending a reset ACK packet instead of data. So how this is being sent? The client terminated. The client didn't have any chance to execute any instructions. After line number 8, we have terminated the client completely. The memory has been wiped out. Then who is sending this reset? We'll see that shortly in the procmon. But in the meantime, what we can do is we can look at the behavior of server terminating prematurely. So let's see that. So I'm going to restart this logging. So we have seen the client termination. We are getting a reset. Now what I'm going to do is I'm going to put a breakpoint here in line number 9 and going to execute the client, start debugging. So again, we should have got our three-way handshake. So this is our three-way handshake, SYN/SYN/ACK. So that is what this particular line is doing. So probably we can receive a little bit data from the client before we terminate. So we have got some data from the client, which is our hello world. No surprise. Now what we are going to do is we are going to stop the server. So what I'm going to do is I'm going to push this here. So we got 2 packets. So I have split the screen here so that you can see what the packets are coming up. So we have the hello world right here. So this is the hello world. We have seen all this SYN/SYN/ACK, push ACK. So we have sent some data. Now what I'm going to do is I'm going to stop the server. I don't have the buttons to press. So what I'm going to do is I'm going to press the key Shift F5. Shift F5 will end the program. So as soon as I press Shift F5, I got this reset ACK, that from server to the client. Now we are trying to answer the question, who is sending this reset packet? We already discussed about it, but we have not seen it happening because our program is ending. Our program doesn't have any role in this because the program is gone. So who is sending this reset packet? We know that the reset packet in the case of server ending is sent somewhere from the server because the port number was there in the packet. So who is doing that? That's where procmon comes into the picture. So let's see that in procmon. So I'm starting debugging. So the server is running. So what I'm going to do is I'm going to put a filter in procmon to avoid other information. So the filter I'm putting is path contains 65432. This is our port number. I'm going to add that to the filter, apply. Okay. So it is the same filter for the port number pretty much everywhere else. We are putting this filter in all the tools to avoid other traffic. Now I'm start capturing. We may get some other events, but for the time being, we will ignore everything. Now, what I'm going to do is I'm going to stop this. Let's see, there is some communication. So there's a disconnect already. Let me clean that up. That is not related to what we are doing. So this is our new server which is running. We have breakpoint in line number 9, and we are going to start the client again. So again, we are sending some data. It's up to you whether you want to send data. So in my case, I'm sending some data, and then I'm going to terminate the server. If you want, you can terminate the client as well. It's going to be pretty similar behavior. And this is what we were looking at. So let me stop capture. If you're using procmon, make sure that you don't run procmon too long. It's very resource intensive application. Just stop the capture as soon as you're done with it so that your resources can be saved. So this is a button to start and stop capture. So don't keep running the procmon longer than you need. I have stopped procmon, so there is no more counting of events here, as you can see. Now, what I'm interested, I have the connect, accept, TCP copy, receive, send, all that kind of things. Now, what I'm interested is disconnect. So from this, we know that 16840, that is a client. Client is a guy who is connecting. We have seen all this. And server is a guy who is accepting. connect, accept. The three-way handshake happened here. This is all related to data transfer of that hello world. Now, if you look at any of these packets, you will see Python in the bottom. So as you can see, Python is doing this. This is our application code. It's all coming from Python. Now, after the send, what we have is a disconnect. We are not doing this in our program, but it has come in the name of Python. So let's see that. As you can see in this stack, you don't have Python. So this is the base of the stack. What is happening? So if you look here, there is a kill process happening. The process has been killed by an external entity. And then as part of that cleanup, it is cleaning up all its objects. Now it is coming to the AFD object, which is our socket. And then AFD is closing the connection. As part of that, it is connecting to TCP IP, and TCP IP is sending that reset packet right here. That's what is happening. So ultimately, it is the operating system. What is the operating system here? It is the NTOS kernel.exe. So this is the single most important binary as far as Windows is concerned. Technically speaking, Windows is this binary, NTOS kernel. So that is the kernel of the Windows operating system. So it is a kernel, the core operating system is doing this cleanup, sending this particular packet, and TCP IP is helping kernel to do that. So do AFD.sys. So the reset packet is sent by the operating system when the application is terminated in a non-graceful way to let the peer know that the other side is terminated. So to summarize, there are two ways of ending a socket application, a TCP socket application. One is closing. We have seen this will send the FIN-ACK, very graceful termination. And the other is ending in a non-graceful way, in which reset. In the case of reset, the operating system is sending the reset packet to the client or server based on the situation. So to conclude, we have seen non-graceful termination of any party. We have discussed a little bit about reset packet, slightly different from the FIN packet we have seen, which is initiated by the application. Reset is not. Reset is sent by the operating system or any other party in between. Now let's see some more states of the socket of our application in the coming lesson.